Hey everybody, good morning, and let's go ahead and get started. Your lesson today is on angles and polygons. And actually I should probably write a little note in here. It's really about interior angles. I should have added that into my presentation here. But interior angles, which just basically represent, interior is another word for inside. Right? That just means the inside angle. So if we're talking about trapezoid or something that looks like a trapezoid, the interior angles are those angles that are right here, the ones that I'm pointing at. Those are interior. Exterior angles, outside angles, exterior, are these angles. If I were to extend the segments outside, those would be exterior. But we're talking about the interior angles. We're talking about those things right there. And we're going to talk about how many degrees are in different shapes. We already know that what a triangle is. So let's get started. Okay, now as we've already discussed before in a previous lesson, we've talked about the Triangle Sum Theorem. The Triangle Sum Theorem states that the angles of a triangle, and it doesn't matter what kind of triangle it is. It could be obtuse, it could be right, it can be an acute triangle, but one thing is for sure, one thing is for absolute certain, the angles will always add up to 180 degrees, no matter what. So those three angles right there, if you don't believe me, add them up, 68 plus 90 plus 22, that does equal 180 degrees. So that should always be the way it is of any triangle. Now let's start exploring different types of polygons. So we just talked about a triangle, which we know has 180 degrees. Well, let's kind of look at quadrilaterals and different shapes after that. Now the question I'm posing in this presentation is how many triangles can be formed using diagonals? Now when I say diagonals, I'm talking about these kind of things. These are diagonals right here. All right, now this says right here without overlapping. Now what I've done so far, I didn't really draw a great diagonal there, but what I've done so far is I've drawn the most number of diagonals, which is only one, in that shape. So when I say like make diagonals, I'm talking about connect one vertex to another without overlapping. Now if I were to connect these, I crossed over, so I broke a rule right there. Okay, so the question is how many triangles can be formed using diagonals? So once you put those diagonals in there, you'll notice that we have triangles. Now those triangles are not equal. Obviously, we've got this triangle is the bigger triangle, and then we have the smaller of the two. But that is not really the point. The point is, what is the measurement of the angles? And we know that the angles of a triangle, because of the Triangle Sum Theorem, we know that the angles are going to add up to 180 degrees. So knowing what we know about triangles, we know that a triangle is going to add up to how many degrees? 180. So that triangle right there, if we're talking about the interior angles, I'm talking about these three. And I'm not saying get out a protractor and start measuring those angles, but we can all be for absolute certain that those all three of those angles add up to 180 degrees. All right, here's another triangle right there, and that's 180 degrees. So now if we think of this quadrilateral as kind of a combining or sum of different triangles, then we can just put those together. We've got 180 plus 180. So the questions that I have on your notes is, okay, how many sides are on a quadrilateral? All right, so we're going to want to pay attention to how many sides are on the shape. So there's 4 sides, obviously, on a quadrilateral. The next thing you're going to want to know is how many triangles were formed. So that we had 2 triangles by doing that. Now remember, like I said, this does not count. Some people are like, oh, I can make more triangles, Mr. Oliver. And I'm like, yeah, you're right, but you can't cross over the path of a diagonal that's already been drawn. All right, so how many triangles are formed? We got 2, and then the sum of the angles is going to be 180 plus 180. Which is 360. So you're, at any quadrilateral, and obviously if it's a square, that's all right angles. That's 90, 90, 90, and 90, of course. And that is going to be, 90 times 4 is 360. Same thing for a rectangle. Both these, both a rectangle and a square both have right angles at each vertex right there. And that's all going to be 360. So any quadrilateral, even if it's like a trapezoid, or even if it's something kind of different looking, something that might not look like a typical quadrilateral, but that has 360 degrees. And that will always be true. That will always, always be true, no matter what. Now, looking at a pentagon, if I look at how many diagonals I can make a diagonal there, and I can make a diagonal right there. That in turn makes 3 triangles. So how many sides are on a pentagon? A pentagon has 5 sides. How many triangles are formed? There's 3. Now I want you guys to think about this, okay? On the last one, we had a quadrilateral that had 4 sides, and we were able to make 2 triangles. This time around, we have 5 sides, and we made 3 triangles. So do you see a connection between those 2 numbers? Maybe you already see it, but I'm not going to say it yet. We'll get to that. So what are the sum of the angles? Well, it's going to be 540, because this is 180 plus 180 plus 180. Sorry, that's kind of the same color there, but that's it. Hexagon, moving on to that one. How many triangles can be formed using diagonals for that one? No overlapping. So we have a diagonal right there. We have a diagonal there. We have a diagonal there. So it looks like we have 4 triangles. So how many sides are on a hexagon? Well, there's 6. How many triangles? 4. Okay, again, let's look at the connection here. We ended up getting, on the quadrilateral, that had 4, and it had 2 triangles. On the Pentagon has 5 sides. That had 3 triangles. Just put a comma there. This one, the hexagon, has 6 sides, and that has 4 triangles. Do you guys see what's going on? Hopefully you see what's happening there with the connection between the number of sides and the number of triangles. So 180 plus 180 plus 180 plus 180. So that equals 720 degrees. A hexagon, and not just a hexagon that looks like this. This looks like a regular hexagon where all the angles are the same. But any type of hexagon, even if it's kind of got a weird shape, like 1, 2, 3, 4, 5, 6. I'm not going to measure those right now, but I can guarantee you that these angles all add up to 720 degrees, guaranteed, no matter what. Moving on to an octagon, looks like I have a part of my animation that still went through, but you're going to see how many triangles you can make. All right, so an octagon, let me refresh your memory. I skipped over a heptagon, by the way. I didn't have a picture of that one for some reason, but a heptagon has 7 sides, obviously. So we went right from a hexagon to an octagon, and an octagon has 8 sides. So how many sides are on an octagon? Obviously 8. How many triangles? 6. And the sum of the angles is going to be 180 times 6. So that's 1,080 degrees. And that seems to kind of make sense. Let me kind of go back a few steps here. Like if we look at the individual angles, I know this picture is not that great, but if we look at these individual angles, well, they're all obtuse. This is an obtuse angle, that's an obtuse angle, this is an obtuse angle, that's obtuse. When we say they're obtuse, they're greater than 90. And they don't look like they're just greater than 90. They look like they're they're much bigger than 90. So, let's say they're like all 140 degrees or something. Then, yeah, you're going to get a big number like we just did. We're going to get 1,080 degrees for the number of degrees in any octagon. Let's go ahead and draw some conclusions from the information we just gathered. What we have is it says the number of triangles formed inside of a polygon is always going to be 2 fewer. That means 2 less than the number of sides. Always going to be 2 fewer. We didn't draw this, but if let's say I did an icosagon. Icosagon has 20 sides, in case you're wondering. I think it does. If it doesn't, you can correct me in the comments. But an icosagon has 20 sides. So how many triangles can you draw in a icosagon? Well, it's going to be 18. And you probably don't want to draw an icosagon. That would be kind of difficult to do. especially if I said, like, draw a regular icosagon that has 20 sides. Yeah, that would be difficult. I would have a tough time with that as a math teacher myself. But we do know that it has 18 triangles. And we know that because that's 2 less than 20. I remember too talking about, we talked about a hectagon. I think I'm spelling that right, but a hectagon has 100 sides. 100 sides. So how many triangles could be in a hectagon? Well, that's going to be 98. It has 98 triangles. So knowing how many triangles in there helps you kind of figure out, it gives you good inference as to how many degrees are going to be in that polygon total. So right here, this is a formula. Right here, this formula is going to give you the number of degrees that are in any polygon. All right, so what we're saying here is we've got 180 times n minus 2. So n represents the number of sides. All right, so a decagon. Well, what's a decagon? A decagon has 10 sides. So now we're going to start out with that formula right there, 180 times n minus 2. And then from there, what you want to do is put in a number for n. Now, n is the number of sides. So we're going to put a 10 in its place. Right, now, what do you guys do here? Do you guys remember your order of operations? Should we do 180 times 10 first, or should we do 10 minus 2? That's right, parentheses first, right? That's the first thing you want to do. Parentheses first, so 10 minus 2 is 8. And now you're left with 180 times 8, which is 2 billion or something. No, it's, I think it's 1,440 degrees. So that's how many degrees total. I'm not talking about just one angle. I'm talking about, I'm going to do a really terrible decagon here, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's just terrible looking. All right. But what we're saying is all those angles, every one of them, there's 10 of them. Every one of those angles adds up to 1,440. Not just that angle right there. Obviously, that angle is not 1,440. What I'm saying is all 10 of them, when you add them up, the sum, meaning add, when you add them up, you get 1,440. So I think that's one of the more confused things that people kind of have when I talk about interior angles. I think they come away from the lesson thinking, oh, did he just tell me that each angle is 1,440? No. What I'm saying is the total. If you're looking at all the angles, just like a triangle, the triangle, each angle doesn't equal 180 degrees. What we're saying is all 3 of them add up to 180 degrees. That would be absurd if you really think about that. Is there any way for any of those angles to be even close to 180? And that is definitely impossible because 180 is a straight angle. All right, moving on to the next example here. Heptagon. A heptagon has 7 sides. All right, so now we're going to plug that into the formula, which is 180 times n minus 2. So what are we going to put in place of the n? We're going to put the 7. All right, so do parentheses first. 7 minus 2 is 5. That is correct. So now just do 180 times 5. I know 18 times 5 is 90, so I bet you this is 900. So there it is. And like I said, a heptagon has 7 sides. I'm going to draw a terrible heptagon. 1, 2, 3, 4, 5, 6. Oh, that's, I even ignore that one right there. But what I'm going to do is, like I said, all 7 of those angles, when you add them up, like some of you like to say, when you plus them, we're going to do some plussing. That's probably not the best word to use, but it always makes me laugh when I hear people say that. There's nothing wrong with that, because I think as long as you're doing math, you're doing something right. But all 7 angles add up to 900. These angles individually are definitely less than 180. All right, and then a triangle. This one kind of the weird one I put in there, but a triangle, just to kind of show you why this formula holds up. Well, a triangle we know has 3 sides, and we already, we came into this lesson knowing how many angles are in a triangle because of the Triangle Sum Theorem. So we're going to put that in there. So 3 minus 1 is or 3 minus 2 is 1, and then you have 180 times 1, which is 180. All right, so that theorem or that formula works with everything. You know, works with a triangle, works with a square, works with a rectangle, works with anything. So that does it for your lesson here. So today we talked about interior angles. Those are the angles that are inside of a shape. In a future lesson, we're going to talk about the individual angles themselves. That should be enough information to kind of figure out what's going on. All right, everybody, have a great day and have a great weekend. And I will be back on Monday. Take care and stay safe.